All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our malaria precision recall and accuracy module. Let's have a look at what we went over today. Yesterday, if you recall, we went over a few topics like the confusion matrix, and we left off with the ROC plot. So today, we're going to pick up where we left off. So before getting to understand the ROC plot, let's recall the two models we had, Model A and Model B. These are our two models here. Our confusion matrix is Model A, Model B. Remember that Model A has the small FN number, which is this one here. That's going to be the false negative number. That's going to be 50. It's smaller than B's false negative number of 700. Now, if we pick out just the Model B, and then we are interested in reducing the number of the false negative in this model, which is 700 right now, then one solution we could do is modify the threshold. So if we had a threshold of say zero point 0.5, meaning that below zero point 0.5 we consider negative, and above zero point 0.5 we consider positive, above would be considered parasitized, and below would be considered uninfected. So this would be an example of that right here. This is our threshold 0.5. Anything greater than that or above zero point 0.5 will be considered parasitized. Anything below the zero point 0.5, like the zero point 0, will be uninfected. Then what we could do is reduce the threshold. So if we reduce the threshold to, let's say, a value of zero point 0.2, you can see here now 0.2. Anything above that would be parasitized. Anything below that would be uninfected. We would see that for most of the predictions, our model is going to say that this is a parasitized output since our threshold has been reduced. Because more than likely, we're going to get a value higher than the zero point 0.2. There's only certain circumstances we'll get a value lower since there's a higher chance of getting a 1 as opposed to a zero point 0.1. So more than likely, we're going to get an outcome that says parasitized. This means that if we have a model prediction of, say, zero point 0.3, which would have initially been uninfected if the threshold was still zero point 0.5, it is now going to be considered parasitized because we lowered our threshold to zero point 0.2. So that zero point 0.3 now would be considered parasitized in this new model. And so this makes it more difficult for our model to have false negatives since our model now has this tendency of predicting that a given input image is parasitized. Like I said, because there's a greater chance of getting a number between zero point 0.2 and 1.0 than you are of getting a number of zero point 0.2 and zero point 0. So we're going to get a lot more parasitized outcomes than uninfected outcomes. That said, we now need to look for a way that we could automate this process. I'm going to leave it there for now. We did take a lot more notes. We did do a lot more graphing. We went over a lot more concepts, but we're going to pick that up tomorrow. And of course, I will keep you posted every step of the way. But for now, it's the Python Papi. You guys stay Gucci.